Good morning, students. Actually, in last class we have discussed about the internal architecture of AVR. So today we are going to discuss what are the peripherals available in this AVR, right? So the advantage of this AVR is it has both digital as well as analog inputs, right? So first it has number of digital IO ports. All the ports are configurable IO ports, right? It can be used to perform the configurable IO operations, and also it has the timers and counters. It depends upon which microcontroller we are using. The number of timers and counters count will be varied, right? So based on that we are using the 8-bit microcontroller or 32-bit microcontroller we are using. Normally we are seeing that in ADMAHA, that is Arduino, we are using ADMAHA 328. Okay, ADMAHA 328 is used in 8-bit microcontroller is used in ADMAHA 328, and in ADMAHA 2560. So that is actually the 32-bit microcontroller. So in that we are using some more timers or counters. Okay, it is actually a 32-bit microcontroller. So in that the number of timers or counter will be used will be varied, and the analog comparator is the most advantage of using this AVR microcontroller. So actually it is separately the analog pin A0 and A1, and which is used to compare two analog voltages, right? And in addition to that it has ADC, which is used to convert the analog input into digital input. It has the 10-bit resolutions, right? And this is also will be differed based on which type of microcontroller we are using, right? So, and you know what are the peripheral functions available? So the heart of an AVR microcontroller is that 8-bit CPU, which makes it truly useful microcontroller, which is built-in peripheral functions integrated into the IC with the CPU logic. Okay. So then control registers. So in addition to the 32-bit general purpose registers in the CPU, so this AVR device have number of control registers, which is used to determine how the IO ports, timers and communication interfaces and all other features of this AVR will behave, right? So based on that we are having the number of control registers to indicate the functions of this AVR. Okay, so then the digital IO ports, you know that all the IO ports are bidirectional ports, and which is used to communicate with the external world, right? So then each port is an 8-bit register, 8-bit wide. Okay, some of the bits are connected to physical pins or on the AVR, right? So if you are taking that AVR that is ADMAHA 328, it contains 8-bit. Okay, 8-bit microcontroller. It also has the 8-bit timer or counter. So it has two forms of 8-bit timer. Okay, so then first type is that clock input is derived from the primary system of the clock. Hence it is called as the timer and counter is synchronous. That is whether we are going to use the timer as synchronous or asynchronous, right? So the first type is that primary system clock is used. Then it is called as synchronous counter. The second form of the clock is that it has the ability to operate in an asynchronous mode using external clock source. So based on that we can divide it into two. Okay, so similar kind of that we are having the analog comparator, which is used to compare two voltages using these two pins. AN0 and AN1 pin is used to connect which is used to compare that analog voltage. Okay, so although this AN0 is defined as positive input and AIN1 is defined as a negative, the relationship between them is not the actual polarity of the input voltage, right? So then it has the 8-bit timer or counter. So it can operate in 4 modes of operations: normal mode, CTC mode, that is clear time on compare, and fast PWM mode and phase correct PWM mode. So these are the 4 modes of operations of this timer counter. So based on these 4 modes, the timers or counter will operate, right? So then these are the communication interfaces which are available in the AVR. So USART, so which is used to perform the serial communication interface, that is universal synchronous asynchronous receiver and transmitter, which is used to perform serial communication. So then this SPI, serial peripheral interface, with high speed synchronous serial interface. Then I2C, that is, it can also be called as the 2-wire interface or twin wire interface, which is used for, most commonly used, that I2C. Okay. So then it supports some of the internal and external interrupts, and also it allows event driven programming for efficient operations, right? The electrical characteristics of this AVR is 1.8 volt to 5.5 volt DC is used, and power consumption is depends upon the frequency and which mode of operation is used. Okay, so and the typical current which will be used by this AVR is approximately 4 milliamps at 8 megahertz and 5 volt in the active mode, right? So for what kind of applications this can be used? You know that today the embedded system is most familiar one, which are what we are using, that is in our daily use we are using these embedded systems, right? And automations and robotics and IoT devices can also be used for this purpose. Okay, so that's all about the today's session. So in next session we will discuss about the remaining things. Thank you.